Right, let's have a look what's going on here. I just refined this and we got some Q peaks 1, 2, and 3, 3.9. That's fairly strong. Let's combine them all together like this. So what could that be? First suspicion, of course, is check whether it can grow. Control G. Yes, there we go. And if we click on that bond, you can see what we've got here is probably a nitrate. So how do you get a nitrate in there? So it behaves Q3. These are symmetry equivalents. What we need to fit a nitrate in here. My suggestion would be to use the FragmentDB tool. I'm going to search for a nitrate. So I hit type nitrate, I hit return. There's the anion. Because there's some symmetry generated atoms, we want to be a negative part, so we get part -1. Free variable, we ignore occupancy 0.5 because it's part -1, and we just simply fit that. So I click on that button, I align the nitrogen of the nitrate with the center peak, one of them with that, and then I just leave it where it is. That looks pretty good. Once you're done, you can click escape down here, and now let's simply refine this, make sure we've got the right settings, shell XL, that's fine, waiting skew updating, that doesn't matter, Control R, refine it. And that shows us the grown structure, and that looks fairly good. If you go fuse, we are back to the asymmetric unit, go purse to just see how the geometry really looks, and that looks all fairly good, so I don't think we've got much of a problem here. We hit refine a few times and see what happens. Or see whether it settles, and it settles slowly, but it does settle, which is good news. And it's there what's moving. It's not surprisingly in here, so we look at kelp. What we've got here, we go anis on this, allow it to be anisotropic, and refine. Doesn't look particularly great, but then you can't really expect that to behave very well, because if you grow this, you can see that this is sort of all on top of each other, so there's a lot of correlations going on. But I think if we carry on in that vein and hit refine again and see what happens, and maybe do a few more cycles of refine, I don't know, 10 cycles, and only look at 4 peaks, we end up with this sort of thing. Nothing's changed. 3.22, 3.21. That's not so bad. So one thing we could consider here is to just select all of those and put an ISO on those, ISO 0.01, just to see what happens. The R factor is 3.21%. Everything looks good, 3.5%. Obviously this has gone up quite a bit. Let's just reduce this a little bit. We click on that, and I'm making the ISO only 0.1, and take this one down here and hit refine again. Now we have something that looks chemically reasonable. The R factor is somewhere in between what it could be and what we want. So I think right now we are not looking too bad here. It settles nicely as well now. 0.007, and it's still not quite down, but it will settle, I'm fairly sure. Now, what we need to consider is what we want for our Z prime. It's currently 0.25, and I think this makes sense. Control grow. Well, maybe it doesn't make sense. That is matter of taste now, to decide what your what your unit here should be, but at the moment we have a unit based on TB2, and just to make sure that the CIF file is correct, I can click on this date modified. This should be that CIF. If I open this with Notepad++, and if you look at the moiety formula, you see it's got half of those and then 2 nitrates per unit. So this is all sorted out for you, and that makes hopefully some chemical sense. And I think as far as that's concerned, one last thing we can check is to just have a quick look at the electron density map and see whether there's anything going on that's too terrible. And well, there's obviously some fairly big peaks around the terbium, but that's maybe just the way it is. But nothing looks too dreadful around the nitrate. So yeah, I think this is probably the answer to this problem. Thanks for using OLX2.